Section 6.2, example 5, constructing a power series from known power series. So use a power series representation for f of x is equal to 1 over x. So we kind of came up with this using our geometric sum. So combined with combining power series to construct a power series for each of the following functions. Ooh, that was a mouthful. Find the interval of convergence of the power series. So we're going to do something similar to, I believe it was a previous section where we're coming up with a power series. This time we're kind of looking to see where they converge as well. So looking at this, let's adjust it so that we could use our geometric sum. So 1 minus, that's going to be a negative x squared. Numerator of 3x. All right, now that we have that, we could turn it into a geometric sum. So s of x is equal to the sum as n goes from 0 to infinity. We have our very first term, or 3x, and from there, we're multiplying it with our geometric sum. This here is our radius, so that is simply going to be negative x squared to the power n. And before we make it pretty, because we definitely could make it a little bit prettier, we're going to find our interval of convergence. IOC, interval of convergence. And what we're looking at here is the absolute value of negative x squared. That should be less than 1. So between the values of 0 and 1, since we're taking the absolute value, all of those values are going to be positive. So we're just looking at the absolute value less than or equal to 1, or less than 1. All right, so from here, we know that these values are going to be from negative 1 up to 1. That's our interval of convergence, but we can make this look just the tiniest bit better. So let's scooch this down. And this is going to be the sum as n goes from 0 to infinity. 3x. And we could move this negative 1 to the power n. X squared to the power n. So it might not really look that pretty, but so negative 1 to the power n times 3x. Or we could even do 3. And then we have x to the 2n plus 1. So add 0. Well, add 0, we're add 0 here. But add 0, we're 3x, 0, 3x. Yeah. All right, there we go. So here is our sum and our interval of convergence. That's for part A. And now let's take a look at part B. Ooh, so here we got to do a little bit more work. So we have 2 values in the denominator. What I really want to do is separate those and find out where. So having it look like, not A, so x minus 1 with the numerator a plus x minus 3 with the denominator b. So if you guys need help with this one, what this is called is partial sums or partial fraction decomposition. So partial fraction decomposition. All right, so the partial fraction decomposition, we're looking for an equivalent relation just with those denominators separated. So here we have our x minus 1 times x minus 3 with a numerator of 1. And we want it to be 2 separate fractions, one with x minus 1 in the denominator. We'll call this a, and one with x minus 3 in the denominator. Call the numerator there b. Partial fraction decomposition, what I'm going to do is multiply both sides by the denominator. So multiplying both sides by x minus 1. X minus 1 times x minus 3. And again over here, x minus 1 times x minus 3. That way here, these two completely divide out. Here, it divides out with this. Here, it divides out with this. And then we're multiplying something here to each of these here too. So what we have here is going to be 1 when we multiply both sides by, I'll kind of write it, making it look like the numerator, x minus 1, x minus 3, and same thing over here. So when it multiplies over here, we get rid of those two. When this whole thing multiplies to this, x minus 1 is divided out, and we're left with a times x minus 3. So a times x minus 3. Similarly, same thing happens over here. These two get divided out, so now it's x minus 1 times b. That's all we have left over there. And there we go. So now there's a couple of different ways that we could go about it. We could, let's say, let x equal 3. So when x equals 3, that equals 3, so that goes to 0. So we have 1 is equal to a times 3 minus 3 plus b times 3 minus 1. 1 is equal to 2b, which means that b is equal to 1 over 2. So we have that value. Now we're going to say let x equal, so over here we let it equal 3 to turn this to 0. Let's make it equal 1 to turn that to 0. So here we would have 1 is equal to a times 1 minus 3 plus b times 1 minus 1. All right. And we have 1 is equal to negative 2a. A is going to be equal to a negative 1 over 2. So now going back to that original relation, we have x minus 1, x minus 3, the numerator of 1. This is equal to x minus 1, a over x minus 1. So this is going to be a negative 1 over 2 plus b over x minus 3. This is going to be a positive 1 over 2, x minus 3. So now going all the way back, looking at the original question, we could say that this is equal to x minus 1, the negative 1 over 2, plus 1 over 2, x minus 3. Now that we have that, we could apply our partial sums formulas. So this was all the partial decomposition of that problem. Now let's look at f of x is equal to a negative 1 over 2, x minus 1, plus 1 over 2, x minus 3. All right, in order for it to be a geometric sequence, we need the denominator to be 1 minus some value over here. So let's fix that. We can take the negative up to the numerator. So this would be a positive 1 over 2 over 1 minus x minus 1 over 2. And we would have 3 minus x. We could adjust this to, we could divide both top and bottom by 3. So we would have 1 over 6 over 1 minus x over 3. So again, what I did is multiply both top and bottom by -1. That's how we got this negative out here. And we were able to get this to look like 3 minus x. And then dividing both top and bottom by 3, we end up with 1 over 6 in the numerator, 1 minus x over 3. And that's how we have this here. More importantly, we have two fractions or two infinite series that we could rewrite. So we have s with respect to x is equal to these two values. So both of them are going to go from n going from 0 to infinity. And it's going to be all of this. So starting off with this fraction, our first term is 1 over 2. And here we just have x to the power n. Now looking at this one, we're subtracting this. This is going to be our first term, 1 over 6 times x over 3 to the power n. And now let's take a look at our interval of convergence. For that first one, we have the absolute value of x being less than 1. That's simple. We have from -1 up to 1. This one, however, we have interval of convergence. We have absolute value of x over 3 less than 1. So that's absolute value of x less than 3. So here we're looking at from -3 up to 3. So it looks like this one ends up winning because this one is inside of this one here. So overall, our interval of convergence is going to be from -1 up to 1. And there we go. Looks like that's it. If you have any questions, please feel free to ask. Otherwise, bye.